press 2. To speak with technical support, press 3. To speak with the warehouse.
You have selected the Train Technical Support line exclusive to residential train dealers of the Mid-Atlantic region. Technical support is available for products up to 25 tons sold through a train dealer. If not associated with a train dealer, you can seek support through your local train parts and supply location. To receive the best support experience, the caller should be on site. Have the model and serial numbers of the product or system products, equipment service literature to reference when directed by the field service representative, and the proper tools to evaluate performance to accurately diagnose the issue. Call resolution and caller safety are of the utmost importance. If caller lacks the technical acumen to safely secure operational data, the field service representative may direct the caller to have a more experienced technician join them on site to continue the support call.
What's going on, guys? So you'll remember this unit from about a week or so ago. I was here. Variable speed train XV system. We were having problems with, somebody was here in January. The guy said that when he turned the thermostat on, sometimes it would randomly come on in cooling when it was set for heat, or come on and run in heating when it was set for cooling. So these have a kind of a one-step solenoid valve on them for the reversing valve, that it doesn't stay energized 24 hours a day, 7 days a week when the thermostat's set for cooling like most systems do, and then when you drop that call for cooling or switch it to heat or turn the thermostat off, it stays unenergized. Every time this thing calls for heat or calls for cooling, it sends a pulse of voltage, DC voltage, 11 and 4 between heating and cooling for a temporary switch, and once the pressures get the valve shifted, it holds and stays there till the next time it shuts off. And it'll pretty much stay there until it gets a call for another mode, and then the cycle changes. But so I put this in it. Guy was here in January. I went ahead and replaced the harness. Tech support told him to do an update on the drive, so we did the update, replaced that harness. I came back because the handful of times I've had that problem, this solenoid has fixed it every time. I've never ran into an issue where the drive was the factor in that. But he called this morning, and they went to dinner last night. It was set for 72 in heat. When they got home, it was 60 degrees in the house and blowing cold air. So I called tech support, and we'll go through the faults real quick on this thing and bring back the fault history on it. And I saw some alerts in here this time that hadn't been seen before. Drive diagnostic, I ran that a while ago. Compressor lube, system oil return, fairly normal. Then I started getting here where it shows it was in limp mode. Then it was telling me that my compressor dome temperature sensor was not attached, and my system's communication error. And then there was another one that was telling me that the suction line temperature sensor was also not attached. Let's see if it's down in here somewhere. EEV limp mode. So see, that one is cleared out, but it was also another one in here saying that the sensor wasn't attached for the suction line when it clearly is. And I checked the DC voltage from here through the sensor. It was reading correctly based on the chart, 55 degrees, and it's about 52 outside. And it was telling me my dome temperature sensor, the compressor temperature sensor, was detached. And then I tested that through here, and it was reading 85 degrees, clearly attached. And then there was another one for a communications fault in there, AC DC something fault, but basically by the book. It was internal system, or CDA, let's see, system communications error fault. There was another one in there, volts DC exceeded, and then when you read over it tells you internal fault failure. So I called tech support. We went through everything, and they're telling me that this drive is the problem. So we're going to change it out. We've got one right here in this box. we're gonna swap this thing out real quick. First thing I'm gonna do is go over here and turn the power off. We're gonna double check that with our meter. Gotta wait for this thing to discharge. Tells you to wait 2 minutes. This thing runs usually anywhere between 300 and 400, 350 to 400 volts DC. When it's powered up, there's 2 test points down here at the bottom. You want to check those and let this thing discharge, which it has. We're going right on down in our DC voltage. Our CDA's gone blank, and we're going to confirm up here real quick that we no longer have high voltage. We do not. So we're going to swap this thing out real quick. And it's not that an issue to change one of these out. So you've got these 3 nuts that you have to get off. And they are holding the plate on. This is the refrigerant line runs through here as a heat sink. And there's some paste and stuff like that you got to put on there, but this is probably, I don't know, for me, maybe in the 8 years or so, 9 years we've been putting these variable speed systems in. I think maybe 4 or 5 of these drives that I've personally replaced, which in the grand scheme of things we put in anywhere between 25 to 50 of these a year. I think the first year we put in like 51 or 2 of them, but we've got a pretty good amount of these units out there, and that's not a bad failure rate, I guess. I don't know. Well, actually it's not that bad, because I know three of the drives I replaced. One, a snake got back in here, a little small snake got in here to the back of the board, and he got cooked. And then I had some kind of frog got down in here one time and shorted the board out, took it out. And then I think a mouse got down in one. So they weren't actually failing because the part itself was bad. It was a critter, a rodent. This is the compressor harness here on the bottom, and it's grounded connected there, and it's ground connected inside at the compressor. But they were basically a snake and a frog and a mouse, so I don't count those. So they really weren't a result from I don't know how they got in. I don't know. It's sealed up pretty good when you get everything together, but they got in there. So it wasn't really, you got to slide these refrigerant lines out. So it wasn't really a fault with the actual equipment. 3 of the 5 that I've replaced. I think this will be number 6. So 3 that I've replaced failed because of a hardware problem. So I mean, it is what it is. Before I get these screws out, we'll go ahead and get these harnesses unplugged up here. This is for the fan motor. It's your high voltage for that. And this is your low voltage with your common, your data, and your hot wire. This is our plug from the reversing valve solenoid. This is the one from the condenser fan motor right here. And this is your main harness, so it's going to have all your sensors and everything. They all come together here to this main harness. It plugs in there, kind of like the 16-pin plug on the variable speed blowers. Then you've got your display assembly plugged in right here. And then right here you have your stepper motor plugged in. And then we have this is one of our pressure switches. There's 2 white wires. Trying to get them off. It's a little, they're on there a little snug. That one off. And then this is your high voltage plug here, which comes down back through here and then ties into your high voltage lines coming in down here at the bottom. So, and last but not least, you don't want to lose what is called the personality module right here. This, it's got the model and serial number to the unit on it. Some more information on the other side, part number. This has to stay, and the air handlers have them as well. When you plug them and put in a new control, which is the drive in this case, you have to plug this back to the new one, and then it downloads the data into the new drive, so the drive knows what unit it's been installed in, knows how to set everything up. Is it a 2-ton, a 3-ton, a 4-ton? These don't come in half-ton sizes on the variable speed systems. You don't want to throw that away. That's why it's zip tied to a separate piece in here so that you can't lose it. They try to make it foolproof, but some people have lost it. Six screws, 3 on each side to hold this thing in. And then you just have to be really careful when you're getting it out. Pay attention to your refrigerant lines. And there it is. It's out. And let's get the new one. Okay, so here's our new drive. We're going to get this thing put in. And we're going to turn it on and run it. Make sure she's operating as she should. Like I said, when you're putting it back in, you want to be careful. Watch out for these refrigerant lines. You want to make sure you're not pinching any wires. Make sure everything's up and out. And then once you get one of these screws in, you're usually pretty good. There we go. Get one on the other side. And we're going to have to put our bead of our thermal paste on there. Put a little bead on that, another little bead on the plate. Maybe you don't have to put it on the plate because I'm not seeing any on the front of this pipe, so and I'm not seeing it on here either, so I think we just have to run it around there. And they are nice enough to include that with it when you get it. Just have to take the tip off of it. And could have made that a little thinner, but we'll shoot some right around here. It's thick. Plus it's cold. Let me get that on there. I don't have to put a lot. Little bead there. Another little bead back there, and then we'll put this plate back on. Get the lines. You gotta be careful about this. You want to make sure your grommet or your little rubber grommet is positioned back in there properly and slid back in there, so it keeps these pipes from rubbing on the chassis of this unit right there. So get that positioned correctly, and then you just gently slide these back in there. And it's a tight fit. And that'll go in there. And I usually like to take a flathead screwdriver and just make sure that thing's not doubled up down there and folded in. It's fully in place. And we'll get our plate back on. Put these lines in there. And get our lock nuts back on it. You don't have to over tighten these nuts. I think the instructions give you some kind of a torque rating on it. You just kind of just snug them. You're not gonna put them in there real tight. I'll do them one at a time, top to bottom. And I'll go back to the top. A little extra turn there. A little extra turn there. A little extra turn there. And we are in business. So now you got to get the wires all plugged back on. Start with our high voltage wire. Right there. Our fan motor, high voltage plugged back in, and get our low pressure cutout plugged back on. Come over here, we'll get the drive plugged back in. We'll get the stepper motor right there plugged back in. And we'll come under here in the bottom, get our reversing valve plugged back in, get our communication wire with our fan motor plugged back in, our low voltage DC voltage control for the fan motor. We'll get our main harness plugged back in. We'll get our thermostat 24 volt common and our data harness plugged back in. And then last but not least, we have to get the personality module plugged back in. All these plugs only go on one way. They only fit one spot, so you really can't mess that up. So let me see. From the old one, I need to take this off. This terminal is used for if you're going to come out and do an update on the drive, the harness that goes to your computer, or the little device you use to load the update plugs there. And the new drive does not come with the cover plug, which is what that is. We've got that back on. And we'll come down here, get the compressor plugged back in. And we got to get our ground terminal back on. And that's really all there is to it, guys. It's not that hard to replace one of these. You do have to have a pre-authorization number from Trane if this system is under warranty. All the other parts in it you can order, put a warranty PO number, or however you guys work it out when you order warranty parts, whatever you use. But this, you have to actually call tech support. They're going to go over your diagnosis with you, go through the faults, confirm your findings, and then they'll give you a pre-authorization warranty number, and you have to have that when you do the warranty on it. When you file your warranty claim, they're going to want that number. If you do not have it, you will not get your credit back. That's just for this one part. And I guess they think the world of it, and they want to make sure for a fact before they just send them out. And you get a history of that. People always turn in TXVs is the one. Bad TXV, bad TXV, bad TXV. And they get the TXVs back, and 10% of them are bad, and the other 90% there's nothing wrong with them. They don't want to go through these things left and right, sending them out the door for everybody that says they got a bad one. They want to confirm the problem with it and check any other things that could be the issue before they give you one of these, which is kind of why we were doing what we were doing. We know how they are with that thing. So we tried the solenoid, the harness, and when the other guy called tech support told him to update the drive, and that would fix the problem, and it didn't. And then I get here this morning and it's telling me I've got sensors that aren't connected and aren't attached. When they were attached, they were reading proper temperatures, and it was showing that internal communications error as well. So we end up with this. So let's go get this thing turned on and confirm that it's going to operate properly. Alright, so we've got it back on, and then I'm going to run the test on the reversing valve. I've got these piercing probes that I've put on these lines. Probably better than trying to shove needle point pins up in here to get a reading, so I'm going to use these piercing tips, and then we're going to run the reversing valve test on it. We'll let it run for a couple of minutes though in cooling, let the pressures stabilize a little bit. Okay, so I've got it running at 100% speed. See our little yellow light? 1, 2, 3. Lets me know all three devices are communicating: the thermostat, the air handler, and the outdoor unit. And we're going to run this reversing valve test. Pressures are starting to stabilize out now. It's 72 in the house, it's 58 outside, so superheat's coming down. You have to wait 10 minutes on these Trane air handlers. That blower, I mean, it's going to run with this, but I like to let one run for at least 10 minutes or more to kind of get stabilized out, let that blower get ramped up to full speed, and then we're going to run this test and see what kind of voltage we're getting down here. First thing I'm going to do is telling me right there that it's running and cooling. Do I want to do the test? Yes. So it's going to switch from cooling to heat, and from heat back to cooling on the test, and then you'll measure your DC voltage on each shift. So I'm going to hit yes. Now it's going to switch to heat. Let's see what we get on our voltage. How well you can read that. So there's our 3.94 volts for our shift in heat. It's going to run for a few seconds, and then it's going to switch back to cooling. And there's our 11 volts DC for our cooling. And that's what it does. Each time the thermostat comes on for a call, it sends that quick pulse to this valve, gets it shifted to the right direction for the mode you're asking for, then it just goes away. Then it stays there, and then every time the thermostat calls, you think that would be some wear and tear issues there. I don't know. Kind of like these little needle probes. I had a set a couple of years ago and I lost them and never replaced them, and I ordered a set of these on. You can get these on Amazon for like $10, and they pretty much fit most sets of meter leads. But that lets me get a real accurate reading. I'll put a little tape on those, but that lets me get a real accurate reading. So we're gonna go in here now real quick. This thing is running at full capacity. And total amp draw on this thing is climbing a little bit. Compressor's gradually ramping up a little bit more, but about 6-7 amps. And this is a 3-ton unit. Total amp draw 6.5. Not too bad. So we're gonna call this one done. I'm gonna cross my fingers, but according to tech support, I'm getting the right voltage to that thing. It's switching. Fault codes in it that weren't actually valid because there weren't anything wrong. There wasn't anything wrong with what it was telling me about sensors not being attached and connected. They were reading temperature, they were reading voltage. Internal failure fault alert in it. Maybe tech support's right. I don't know, but they sure love this thing. You better be right when they call them, because they'll be hard pressed to do anything for you. So anyway, guys, appreciate you watching. Like, subscribe, and we'll see you on the next one.